My name is CHIRAWAN and I'm from Ponmon. My course is Microelectronic Engineering. My metric number is 1710105004.
My name is Going Sid from Microelectronic Engineering. My matrix number is 1710105008.
My name is Ong Tiang from Electronic Engineering. My matrix number is 1710315594.
My name is LIAU from Electronic Engineering. My matrix number is 1710327743.
What is atom? Atom is extremely small. We cannot see with our naked eyes. Atom is an element containing three basic particles. The three basic particles are protons, positively charged, neutrons, no charge, and electron, negatively charged. The proton and neutrons are located at the nucleus, which is core of the atom, while electrons is located at the shell. What is semiconductors? Semiconductors is the material between conductors and insulators in its ability to conduct electric current. The most common semiconductors is silicon, germanium, and carbon, which contains 4 valence electrons. Here is the energy bands for semiconductors. The band outside the valence shell where it has free electrons is called conduction band. Another name for valence band is also called valence shell. Valence band and conduction band are separated by energy gap. For semiconductor material, the energy gap is narrow compared to insulator material. It is to enable some electrons with enough energy to escape from valence band to the conduction band easily. When the temperature is high, the electrons in excited state and have enough energy to jump from valence band to conduction band. If the energy is lost, the electron will return back to the valence band.
Conductors are materials that easily conduct electrical current because of very low electric resistance in the flow of electricity. The conductor only have one valence electrons that binds very loosely to the atom, so that the electron in the conductor only needs a very low energy to break the bond and to be a free electrons. The example of conductor are aluminum, copper, silver, and gold. Insulator. Insulator are materials that does not conduct electrical current due to the very high electrical resistance. The valence electrons of insulator are tightly bound to the atom so that the electrons cannot move freely. The electron in insulator needs very high energy to break the bond in the atom. This results in the insulator do not conduct heat and electricity all the time. The example of insulator are rubber, woods, fabrics, and glasses. Energy band diagram can show clearly the comparison between conductor and insulator. Energy gap is the difference in energy between valence band and conduction band. In conductor, the valence band is filled with electrons overlapped with the empty conduction band. In general, both of the states can occur at the same time. The electron can move inside partially filled valence band or inside two overlapping bands. In conductor, there is no band gap between valence band and conduction band. Therefore, in insulator, the valence band is fully occupied with electrons due to the covalent bond. The electron cannot move to conduction band because they are locked up between the atoms. To achieve the conductivity, electrons from the valence band have to move into conduction band. A large amount of energy is needed for electrons in valence band to move into conduction band. This results to a very big energy gap between both of the bands. Insulator is to be said cannot conduct electricity.
Silicon can be divided into two groups. There is intrinsic and extrinsic. The example for intrinsic are silicon and germanium. Extrinsic can be divided into n-type and p-type. pentavalent atom is often called as an acceptor atom, as the trivalent atom contains an electron. A hole acts magnetic carrier in the p-type semiconductor. For n-type semiconductor, the pentavalent impurity atoms are added into intrinsic silicon or germanium. The pentavalent atoms are absorbed by valence electrons such as arsenic, phosphorus, and antimony. Each pentavalent atom forms 4 covalent bonds with 4 adjacent silicon atoms, leaving one extra electron. This electron becomes a conduction electron as it is not attracted to the atom. Because the pentavalent atom gives out an electron, is often called a donor atom. The majority carriers in n-type semiconductor are electrons.
Conduction in semiconductor. As we know, electrons of an atom can exist only within prescribed energy bands. Each shell around the nucleus corresponds to a certain energy band and is separated from adjacent shells by band gaps, in which no electron can exist. Figures show the energy band diagram for a pure silicon crystal with unexcited atoms. There are no electrons in the conduction band. This condition occurs only at a temperature of absolute 0 Kelvin. Conduction, electrons, and holes. An intrinsic silicon crystal at room temperature has sufficient heat for some valence electron to jump the gap from valence band into conduction band, becoming free electron. Every electron raised to conduction band by external energy. There is one hole left in the valence band, creating an electron-hole pair. Recombination occurs when a conduction band electron loses energy and falls back into a hole in the valence band. Free electrons are being generated continuously while some recombine with holes. Electron and hole current. When a voltage is applied across a piece of intrinsic silicon, the thermally generated free electrons in the conduction band, which are free to move randomly in the crystal structure, are now easily attached toward the positive end. This movement of free electrons is one type of current in a semiconductive materials and is called electron current. Another type of current occurs in the valence band, where the holes created by the free electron exist. Electrons remaining in the valence band are still attached to their atoms and are not free to move randomly in the crystal structure, as are the free electrons. However, a valence electron can move into a nearby hole with little change in its energy level, thus leaving another hole where it came from. Effectively, the hole has moved from one place to another in the crystal structure. As you have seen, conduction in semiconductor is considered to be either the movement of free electrons in the conduction band or the movement of holes in the valence bands, which is actually the movement of valence electrons to nearby atoms, creating hole current in the opposite direction.